voltage minimum happens in transmission line in the Smith chart. Okay, Vmax and Vmin. Okay, so this is the wave. Okay, Vmax is the maximum value of voltage. Okay, Vmin is basically the minimum value of voltage, okay, which travel in the transmission line. Okay, so the rule of thumb, Vmin, so Vmax happen at wavelengths with generator equal to 0.5 lambda. Okay, Vmin happen at wavelengths with generator equal to 0 or 0.5 lambda. Okay, Vmax happen at 0.25 lambda. Okay, Vmin happen at 0 or 0.5 lambda. Okay, so basically minimum and maximum happens at load. Okay, maximum value, minimum value, voltage happens at load. Usually happens at load. Okay, what happens to the load? Okay, if maximum value, if minimum value. So that's why you have to identify where the Vmax and Vmin. Okay, the locations of Vmax and Vmin. Okay, so this is the rule of thumb. Okay, so RL Z0 maximum at the load. Okay, RL less than Z0 minimum at the load. Okay, so this is basically based on the circuit calculations. Okay, so ambil gambar ke? Okay, boleh. So now given ZL equals 100, okay, Z0 equals to 50. Okay, so ZL equals to 100 plus J100. Okay, Z0 equals to 50. Okay, so normalize 100 plus J100 divide by 50, so you get 1 plus J1. Okay, can you plot 1 plus J1 in the switch chart? Plot 2 plus J2. Jangan marah. Okay, 2 plus J2. Plot in the Smith chart. Example. Okay, 2 plus J2. 2 plus J2. 2 plus J2. Plus J2 nak buat circle ke tak? Tak payah, tak boleh. Okay, 2 plus J2 dapat? Okay, so draw the line pass through the Smith chart. Terus. Okay, terus straight, terus. Okay, so look at the wavelength to its generator scale. Same like the last example. Okay, wavelength towards the generator scale. Okay, so find the value of wavelength at J2 plus J2. Okay, so I get 0.21 lambda, betul? Sama macam tadi, betul? Okay, so I get 0.21 lambda. Boleh? Terima? Sama? Do you get the same value? 0 point? Okay, tak apa, kita kena 0.21 lambda. Okay, at ZL given 2 plus G2. Okay, so just now, so I said Vmax happens at 0.25 lambda. Okay, 0.25 lambda is over here. Okay, maximum voltage happens starting from here. Okay, 0.25. Okay, so basically how many lambda is the Vmax? Okay, so 0.25 lambda, okay, minus this, the ZL location, which is 0.21 lambda, so you get 0.04 lambda. So this is Vmax, happened at 0.04 lambda. Senang kan? Senang je. Okay, so Vmax happens at 0.25 lambda. Okay, ZL is situated at 0.21 lambda. Okay, so we're going to find out what is the lambda, or where is the locations of V maximum happen. So therefore 0.25 minus 0.21 lambda. This one, inilah. Okay, boleh? So that is V max. Okay, V min happen at 0 or 0.5 lambda, betul? Which is towards the left of the Smith chart. Sini. Okay, kosong ataupun 0.5, 0 or 0.5. Okay, so therefore you have to add the value. Okay, this one is 0.04. Okay, so it happens at 0 or 0.5 lambda. So from here towards the 0 or 0.5 lambda. Okay, so 0.25 lambda plus 0.04 lambda. So therefore you will get 0.29 lambda. Okay, V min happens at 0 or 0.5 lambda. Okay, now we are going to know the exact locations. Okay, the exact length of transmission line. Where is the V min? Where is the V max happen? Okay, so V min happens at 0 lambda or 0.5 lambda. Okay, now the ZL is here. ZL is situated at 0.21 lambda. Okay, respect to the length from the V max is equal to 0.04. Panjang ni lah, this length is 0.04 lambda. Okay, V min happens here. Okay, so which means that you have to move from here towards the 0 or 0.5 lambda. 0 lambda lah, senang. Kita ambil 0 lambda. Okay, so therefore 0.25 lambda plus 0.04. So you get 0.29 lambda. V min happen at 0.29 lambda. Transmission line. Transmission line with max min, max min, max min. So at what location the voltage maximum happen, the voltage minimum happen? Okay, given this is the load. Okay, this is our transmission line. Imagine Vmax, Vmin, Vmax, Vmin, max min, max min. So load 0.21 lambda. Okay, so where is the situations of Vmax and Vmin happen? Over here. Okay, so in general terms, Vmax happen at 0.25 lambda. Minimum happen at 0 or 0.5 lambda. Why 0 or 0.5 lambda? Because one Smith chart is equals to 0.5 lambda. Kita kira one cycle tu macam 0.5 lambda. Okay? Faham? Okay, basically why do you have to calculate the Vmax and Vmin? Why do you have to know where is the Vmax and Vmin situated? Kenapa awak cari Vmax and Vmin location? Why do you have to find the locations of Vmax and Vmin in transmission line? Tak faham sebab tak nampak kan? What happen is Vmax happen to the transmission line. What happen if the V is more than the Vmax value? Overload. 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 Station rosak. Disebab overload akan menyebabkan station rosak. Overload. Okay, what happens to the load? Or what happens if Vmin happen? Not enough power. Under tak suka, tak cukup supply. Okay, so imagine this is high voltage, bukan rumah lah, high voltage transmission line. Okay, if Vmax happens, so there are lot of losses is high. Okay, so that's why the correction, power factor correction, lead and lag, power factor correction, Vmax, Vmin, so that the Vmax and Vmin must be in the range of the one that you desired. Okay, if something happen, Vmax happen, high voltage line, tiba-tiba ada outage. How do you check the Vmin and Vmax? Takkan nak naik atas tinggi, check satu-satu guna meter. Based on the length of the transmission line calculation. Okay, so berapa? Occurrence dia berapa? At 0.25 lambda. For example, at 0.29 lambda Vmin. At 0.29 lambda Vmin. So corrections at that length of transmission line. Letaklah insulation ke capacitance, anything else, etc. If high voltage, nak buat macam mana? Letak correction. Okay, so that is basically why we have to find the Vmax and Vmin. Vmax and Vmin related with VSWR. Okay, Vmax divided by Vmin akan dapat VSWR. The higher the VSWR, the higher the losses. Okay, that's why you have to locate where is the Vmin and Vmax. Okay, so this is for high voltage system. Okay, kalau rumah tak ada masalah lah. Okay, this is for high voltage. Okay, low voltage macam ni tak ada masalah. Panjang macam mana pun tak ada masalah. Buat lipat dia macam mana pun tak ada masalah. Okay, high voltage. Okay, awak belajar power systems engineering kan this semester. Ada low line, medium, high. So this is for high voltage. Okay, you can see two balance wire, tiba-tiba ada insulator yang kaca tu. So that is basically the correction. Okay, tengah-tengah transmission line panjang ada satu pula bulat. Okay, next one. Okay, the application wise. Okay, Smith chart tak nampak. So bila kita terangkan application wise, kita boleh nampak dekat mana. Okay, power factor yang kita claim tu itu untuk medium to low voltage. Okay, kita boleh claim. Tengok dia punya, kan ada kan claim kan, nak check Kalau high voltage macam nak check, nak claim macam mana? Siapa nak bagi claim? Saya tak nak claim. High voltage. Astagfirullahalazim. Okay, boleh? Questions? No questions. Okay, sebelum saya, before I stop. Okay, so basically the questions in the question related to for example test is like tutorial questions. Okay, given the value of Z0, okay, the impedance, the C, okay, you need to find reflection coefficient. Example number 1. Okay, voltage standing wave ratio S. Okay, ni semua dalam slide ada ni, tak gambar lagi. Okay, the load impedance, the input impedance. So, which means that all the exercises from exercise number 1 and exercise number 6 to be in one question. Okay, understand? So that's why kita buat satu persatu. That's why we go one by one, slow and steady. Okay, so next week we will justify the answer in the Smith chart according to the calculation method. Okay, VSWR equals to Vmax divided by Vmin. Okay, Z0 is equals to yang ni, Z0 beta Zin equals to this equation. Masuk dalam calculator. Dapat sama tak dengan Smith chart? Okay, now you more appreciate Smith chart rather than the calculation. Okay, so next week kita rehat 10 minit tadi kan. Jadi 2 jam setengah. 2 jam. Okay, 12:40. Questions? Any questions? No, no questions. So please bring your Smith chart next week. Okay, tomorrow no class. Okay, assignment